Recording. Recording now. Push pause because my thing's not up yet. Boop. Why do we always get our damn electronics out? I could one day. When? Because I am kind of asked to do so. I would be okay with just whiteboards. I think one day we put every electronic on this desk and see how you guys handle it. Lily's already addicted so much. No, you're not recording. Oh, it's okay. Breaker, breaker, 125. Those are called supplementary angles because they add up to be 180 degrees. Okay, and then we have other things that, like right here, this is a 90-degree angle, but I told you this angle right here is 47. What's that? How did you know that? Have to add up to be 90, so use those. These two. These guys are called complementary. You guys remember this a little bit? That sucks. Well, you did. Okay. Anyway, huh? I suppose you might should even learn that in 6th grade. Okay. So those are 180 degrees. So notice this is a straight line, right? Isn't this also a straight line? Okay. So therefore, if he's 100, what's this guy? Has to be 80, because once again, this is 180 degrees. A line is 180 degrees, right? Okay. If he's 80 degrees, what's this guy? Okay, does everybody understand that? That wasn't pretty hard, right? Okay. Yep, that does that. So notice I'm going to say this side right here is A, B, C, and D. Notice, vertical angles are like angle B and angle B. So, notice angle A is congruent. This means congruent, by the way. It's equal with the tilde above it. Okay? Is equal to angle C. Okay? Notice these two, angle B and angle D, are called vertical angles. They're the ones that are on opposite sides of where two lines intersect. Okay? So, once again, the sides that are opposite when angles intersect are always equal of each other, because knowing the fact that, notice like right here, why are these two guys equal to each other? Well, they share a common angle that they have to be supplementary to, don't they? They're sharing an angle that they have to be supplementary to, don't they? So that's why they have to be the same. Right? These two angles right here have to be the same because they're sharing a supplementary angle as well. So opposite angles of two lines that intersect are called vertical angles, and they will always equal. Does that make sense to each other? Everybody get that? Yes or no? Okay. That's important with our lesson today, okay? Alright. Can I go on? Alright. Now, if you have two parallel lines, once again, the little arrow will indicate parallel. Should have learned that last year as well. Should have. Even if you didn't, don't let your mind right now. Okay? Those two lines are parallel. Okay? So, if I intersect it by a line, which we call a transversal, okay, we have how many angles just now are created? 8. 8, okay? So I'm going to have angle 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay? Alright, let's name all our vertical angles. Who are congruent just because they're vertical angles? So angle 1 is congruent to angle 3 because once again they are on the opposite sides like we just discussed, right? is congruent to 7? Okay. And 6 is congruent to angle 8. Is everybody okay with that? Can you see those ones are being congruent because they're vertical angles? Yes, no, maybe so. Does everybody understand what a vertical angle is? When two lines intersect, they're on the opposite sides or the opposite points, right? All right, Patrick, you just said, well, angle 1 and angle 3 are the same as 5 and 7. Can you explain why? Yeah, these two are vertical. These two are vertical. They're not vertical angles themselves, are they? Okay, so let's think about this. What is parallel? They never intersect. So guess what that means? They have the same what? Anybody remember? Slope. Notice that they both have to rise and run the same amount, or they would sooner or later intersect, wouldn't they? Does that make sense what I'm saying? Okay. So they're the same angle. So if a line goes through it, they go through them at the same angle. Okay, so just this is exactly what I wanted to know. We're going to now talk about what we call corresponding angles. Or this is vertical. Okay, corresponding angles. Okay. Angle 1 is congruent to who? On the one below. Angle 5. You see how these guys are in the same position? Right? You have it both above the line but to the right of the transversal, right? Both above their line and to the right of the transversal. They're in the same position, correct? Those are called corresponding. So angle 1 is congruent to angle 5. Right? Is everybody okay with that? Okay. Then you guys still have your picture, obviously, right? Who else is? Angle 3 is congruent to angle 7. Angle 2 is congruent to 8. Angle 4 is congruent to 6. And we have all of them, right? Those are guys are called corresponding angles, meaning they're in the same corresponding spot of the two parallel lines. Should have known that last year, to be honest. This should be somewhat of a rookie. Okay? We also have what we call alternate interior and alternate exterior. You guys remember those words? No? Oh, you guys are killing me. I bet you. Come on. Alternate interior. Let me hear you show you why. Who is angle 1 congruent to up here? Angle 3, right? Because of vertical angles, right? But angle 1 is also congruent to angle 5 because of corresponding, right? Does that make sense to everyone? Okay, let me ask you this question. Abigail, I have $5. You have $5, then, because we have the same amount. Well, if you have the same amount of money as he does, how much money will you have? Why? Because I have 5, she has to have 5, and you two are equal. So therefore, can we just get rid of her and say that we are the same as well? Right? That's the same idea. Notice, we say up here, angle 1 is congruent to angle 3. But angle 1, angle 3 is congruent to angle 1, but angle 1 is congruent to angle 5, so what do we know? 3 and 5 are the same. Does that make sense? Let me show you again. See how they're alternate? What does alternate mean, you think? Opposite sides, right? Alternate interior. What does interior mean? seeing this, or is this something not big deal? You see how we're converting them, making them equal to each other? And what was the other alternate exterior pair? 2 and 6. Those would also be equal. Okay? No. Well, certain ones are going to be some, like 4 is not equal to 1. Right? So therefore 4 and 8 are equal, so 1 and 8 are equal. Right? What are these guys called? I just gave you a word for them. So these guys add up to be what? They're 180, so they're supplementary equals, right? So there's actually another rule that says same side exterior are supplementary. Because 4 and 6 are equal, right? And then 1 and 4 are supplementary, so therefore 1 and 6 are supplementary. Okay? Well, isn't 2 and 4 equal to each other? Well, 2 is equal to 7, and 2 is equal to 8, and 8 and 5 are supplementary. And 2 is equal to 4, so 4 and 5 are supplementary. Those guys are called same side interior. Same side, anytime you have a same side interior or exterior, they are supplementary. So are they equal? No, they're not. Could they be equal? Well, the only time they could be equal is if every angle is 90 degrees, right? But angle 1 and angle 6 have to add up to be 1. 4 and 5 have to add up to be 1. Because 1 and 5 are the same, right? And 4 and 1 supplementary, so therefore 4 and 5 have to be supplementary. We don't really need those for today, though. Okay? All right, is everybody okay with those? Because we're going to need those for today? Yes, no? All right. All right, so, ladies and gentlemen, let's think about this. Okay? To be honest, if I have two angles, let's just show you here. So like, for example, if this guy is 40, and this guy right here is 60, okay, and then I show you over here, this guy is 40, and this guy is 60. What do we know? They have all the same angles, because what does this guy have to add up to? The triangle has to add up to be what? Does everybody understand that a triangle has to add up to be 180? So therefore, 40 plus 60 is 100, plus how much more than 80? This guy has to be. Now, I want you to be honest with me. Let me go. Okay. I don't know if I still have geometry sketch pad on here. Yeah. Yes, it's still the same angle. But let's say I stopped right here, right? Okay. Let's say I stopped right here, and I stopped right here, and I wanted to create that angle. That looks about parallel, doesn't it? Okay. Well, because this side is shorter than this side is going to take a lot longer to reach where this guy was. Does that make sense what I'm trying to get at here? Because it's a longer side. So this is 40 degrees. Okay, so it's going to reach it sooner or later, just like this one's going to reach this one over here. Correct? And it's going to form, because this is, we're making a triangle, this half is 180 degrees. So the sides automatically have to be proportional or they wouldn't reach out to the sides. Does that make sense what I'm trying to say? Like, for example, if this was 3, and this was 6, and this is 4, what does this automatically have to be? It has to be this, right? Because it has to be proportional. If not, if they're not proportional, that side length would not get over there, right? To complete the triangle. Does that make sense what I'm saying? So, what I'm trying to show you today is this. Is we're going to look at certain ways, like beforehand, for us to prove that they were similar, is we saw that all the angles were already given saying that they were equal to each other, right? What we were doing was proving that the sides were proportional. We were assuming something that we shouldn't have assumed already. Does that make sense? So what I'm trying to tell you is this. If you have two angles, which we call angle-angle similarity, if you have two triangles and two of their angles are the same, those triangles have to be similar. Because if you have all three of the same angles in a triangle, the sides automatically have to be proportional. That's what I'm trying to get at here. last assignment, we assumed that all the angles were congruent, but were they? No, because if they came out not proportional to side lengths, then obviously all the angles weren't the same, were they? Does that make sense what I'm saying? We had just assumed by using the side, we were trying to prove what we call the other theorem, side, side, side. Okay? We talked about side, side, side congruency. You had angle, angle, side. You had angle, side, angle. You had side, angle, side. You guys remember some of those things from last year? No, we don't have that one. Doesn't work. Nice try, though. It's not approved. Okay? And then, so you have angle, angle, similarity, side, 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 similarity, and then we have automatically the other one we could do is side, angle, side, similarity. Okay? Those are the three ways that we can prove if something is similar. Let me give you an example of what I mean by each. Okay? Let's say you have this triangle. How many triangles do you think we have? I'm going to call this A, B, we have two triangles at one. Okay? So I'm going to separate them. So I have A, C, E. Does everybody see that? And then who else do we have? We have B, C, and D. Does everybody see that? Hide it all. No. Nice question, John. Oh. All right. So, ladies and gentlemen, are these guys similar? First off, these guys are parallel. Okay? Now let me ask you something. See how angle C is in both of them? So we already know that angle C is congruent to angle C. Anybody know what we call that? It's called the reflexive property. Obviously, something's equal to itself, right? If I cloned me, right, I should have that person exactly the same weight, height, everything as me, right? Should be the exact same. Completely proportional, completely equal as well, right? Does everybody understand that? Okay, so right there, those angles are the same. Okay, when you see parallel lines, what should you think about? What we just talked about, the corresponding angles, the alternate interior, the alternate exterior. Okay, we should think of those. Okay, does everybody see this angle CBD? You guys know how to write an angle, by the way? Because notice, what if I wanted this side instead of that side? Because I can't call that just angle B, can I? Because what is angle B? Is that the top one or the bottom? So how we do that is we always make angles with three sides as we go. Okay? So you go C, B, D would be the top. Does that make sense? The bottom angle, what would we call him? A, B. Does that make sense? So therefore, let me get rid of those tick marks, because that's not correct. Okay? Who is angle CBD congruent to though? CBD? CAE. Why? What did we call them? Why? Well, you got to give me a justification. You can't just say they are. Give me a justification. Tell me why. What did I call them just barely? Look in your notes. What did I just barely call those angles? They are corresponding angles. Okay? We are doing little proofs. Have you guys ever heard of proofs before? Okay? You cannot say something is true unless you know it's true by like here. I can't say angle C is not congruent to angle C unless I have a theorem behind, such as the reflexive property. Like this angle C is congruent to angle C by reflexive. Okay? I know angle CBD is congruent to angle CAE because of the corresponding angle. I have a reasoning why I know they're true, why they're equal to each other. I can't just say because they are. Okay? That's not how math works. How math came about is because we have proven that it works through other math justifications. Okay? Yes, sir. reason why they're called that is because notice once again this is called that transversal side, which we just talked about with two parallel lines, right? So those two are once again corresponding angles, and that's why, because that is going out at the same slope, intersecting these, right? Okay, what else do I know? What about this angle? Who do I know what this angle is? Not C, and what A? Well, we can call it angle E, but what is it? We can say angle CDB is congruent to who? CBA, because of corresponding angles to it. We have to have a justification. So therefore, CBB is congruent to CAE because of corresponding angle. And this angle is congruent to that one as well because of corresponding. Right? And we have justification. Did I actually have to know that these guys are corresponding to know that it's congruent? What's another method that I could have used? Well, these two are congruent, so therefore they're the same angles in both, right? So if 2 out of your 3 angles are the same, what does it mean about the third? They have to be the same. So that's why I only have to have 2 of my 3 angles be the same, because the third's going to come along after I've proven 2 of them are the same. Does that make sense what I'm trying to say by that? So therefore we have angle-angle association. That just was proven by angle-angle similarity. Somebody tell me my similarity statement there. Remember the similarity statement is like triangle ABD equals CFG. Triangle AQE base equals to triangle congruent. Well, we can't say congruent. Sorry, sorry, that's my fault. We can't say they're congruent. We don't know that it's side length. Well, because first off, look at that. Are the side lengths the same? No. So we know they're not congruent, but we believe they are similar to. Okay, so B, C, E. Does that make sense to everybody? We okay with that? Okay. Let's see if we can see another one. Are those triangles similar? Okay, so once again, we're looking at, we have 3 ways to prove it. Angle-angle similarity, side-side-side similarity, or side-angle-side similarity. We have those 3 cases. Those are the 3 cases that we can prove that angles are similar. First off, do I have any of my sides? So are we going to use either side-side-side or side-angle-side? We're not going to use either of those. So our goal is to try to prove this by angle-angle. Well, I do know angle A. Angle A is congruent to angle E. How do I know that? It was given to us. It was given to us, right? If it was already told to us, we just write it was given. Okay? Does that make sense to everybody? What else? I just barely showed you right before. Do we have any parallel lines? Do I have any tick marks saying that they're parallel? No, so I can't assume that they are, right? They could be slightly off. Could be rising 3, running 2 on 1, and rising 3, 1, running 2 on 1. It's so much the same, but we can't say it unless it's the same, right? That's what about math. We can't assume things, right? We have to be known. Okay. What other did we study? So there's no parallel line, so it can't be alternate interior, it can't be alternate exterior, it can't be corresponding. What other things did we talk about? Vertical angles. Do we have any vertical angles up there? Yeah. Give me this angle here. What would we name this angle right here? Go ahead, April. I can't name it C because C has all 4 of those points, right? So let's see. This one, this one, this one, this one. Can't be name that. Okay. BCE. Okay, E And why? BCA. So therefore, B has a single tick mark, so B kind of corresponds with the A, doesn't it? So therefore, DCE. They should be the same. And what's our reasoning? I can't just say that they are. What's our reasoning behind it? They are vertical. Okay? Everybody there with me? Okay, so we got to look for those things. Notice whenever two lines intersect, think of vertical angle. Maybe write that down. You should have that in your notes. Okay? Whenever you see two lines intersect, look for vertical angles. When two lines intersect. Okay? Now, how do I know, are these similar? Are these triangles similar? Why? Angle similarity, right? So therefore, then I write triangle ACB is similar ECD. Notice A has to correspond with E, right? Which they do. C corresponds with C and D corresponds with D, right? And then we say our justification. We know these are similar because of angle similarity. Okay? Alright. Let's go to a side situation. What does that mean, ladies and gentlemen? So for example, if I have 10 and 7, and I have 30 and 21, and I have 50 and 35. Okay? Are any of these angles corresponding? Or do I know if they're equal? I don't know if they're equal, do I? But, what do I have? I have every side, don't I? Okay? So if I can prove that these sides are proportional, then I know all the angles have to be the same or they wouldn't have been proportional, right? Does that make sense? So what do I need to do? Set up the ratio. Well, who corresponds with 7? Because he's the smallest side, has to correspond with the smallest side, right? Okay? 7 over 10. Okay? Who else do you want to go with? 21 and 30. And then 35 and 50. Okay, can 7 and 10 reduce down? Do they have anything in common? Okay, how about 21 and 30? Do they have something in common? You guys see how they have a 3? So that comes down to 7 tenths. Oh, look, that's nice, huh? Okay, how about 35 and 50? They have a 5. That is 7 tenths. Because sides, whatever, blah, 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 are all proportional, therefore, I know that this triangle is by side similarity. I know these two are equal. Okay? Does that make sense? Now, what if all of a sudden this was 40 out of 50? It wouldn't be proportional. It would not be similar anymore because the proportion didn't work for all three sets of pairs of lanes, right? Okay, that one thing, just like we learned yesterday, you take everything out. Right? And therefore they're not similar because therefore if the lengths are not the same, therefore the angles aren't the same. Okay? Does that make sense to you guys? See what I'm saying by that? Okay. And last but not least, like when we have a situation like this. Okay, and tell you that this guy's congruent to this guy, and then this guy's 5, this guy's 10, this guy's 15, and this guy's 30. What do you guys think that we're going to have here? Do we have two angles? Do we have anything to prove another angle? Angle is the easiest one to prove. Because you just got to find one more. But notice, they're not parallel, they're not anything, I can't say anything. Okay, only thing I know is that those two angles are the same. So I only have one angle, but I got two sides. So therefore we set up the proportion. Now, if these two sides are the same proportion, and those angles are the same, that means that they're going to come at a certain distance, and therefore for those guys to connect, that third side has to be proportional to him, and basically then we go back to side, side, side. Does that make sense? Well, that's what we are doing. We are improving, but that's what I mean. Because that angle's there, then that means that these sides would also have to be proportional, because they'll come out in the same length, right? I mean, not same length, but proportional as they come out, so therefore the third side has to be proportional as well, which then reverses back to kind of like side, 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 like here. Okay? So let's set up our proportion. Okay, we need to set up a proportion for me. Who corresponds to 5? Okay, so 5 over 10 and 10, 30, right? You say 30 or 20? Okay, we reduce down 1/2, 1/10. 36. You guys want to know another way to do it? You do your cross here. What's 5 times 30? 150. What's 10 times 15? 150 equals 150. That also proves. Does that make sense? Ladies and gentlemen, that's our work today. You have to prove, okay, sometimes you're going to have to say, well, I know this angle is congruent to this angle by angle. Does that make sense? But I have to make you prove that first. So let me explain that to you when we get hand the cut. I'll show you one example of how I want us to do it. I didn't make it, so I don't have to make any. You don't? I have little minions to do that. No, I'm good. You're far away! Are you giving me sap? Okay, let's look at something. Okay. Okay, let's look at number 2. Okay? Everybody look at number 2. This is what I am looking for on your homework, okay? So notice they got parallel lines, correct? Okay, we got this guy. So we have P, B, C, and A and B. Okay, they do tell us this. What does that mean? They are parallel. Okay, I would like you to tell me, are these similar? Well, we have to prove it to ourselves, right? What do I know? How do I know that this angle and this angle are the same? Not because of the parallel this time. They are called verticals, right? So I know angle, I want you to write this off the side. ECD is congruent to, who corresponds with E? Do you guys know who corresponds with E? It is B. It is B. And anybody understand why? Let's go to our parallel lines real quick. Okay, if this guy's parallel, here's our transversal. We got one below. So we're going to notice they're inside the angle, so they're on opposite sides, so they're alternate interior, right? And so therefore they are congruent as well. For these guys, yeah, that's correct. So I can say angle E is congruent to angle B because of alternate interior angles, right? And then I can say, okay, ECB is congruent to BCA because of verticals. You guys see how I proved it? I just didn't say they were congruent. I said they're congruent because. Okay? Does that make sense? I don't want to just say they're congruent. I want to know why they're congruent. Okay? Because if not, you're just telling me I believe they're similar. You know what I mean by angle. But if I say these guys are congruent, then now I know, what does it say on there? CBA. Triangle CBA is similar to triangle who? Who corresponds with C? C does, doesn't he? CED, right? And why? Because of angle-angle similarity. And we proved that those angles were congruent, huh? angles are the same, I don't want to see it. Does that make sense? Okay, we cannot say something is true until we have proven that it is true. Okay? You get what I'm trying to go for. Okay, so if that's meaning on the sides, you have to prove